Okay, so this is the follow-up video for the review. So I had 4 review problems typed up. I made them up, so hopefully there aren't any big mistakes here as I go. And the 4 problems are practicing with each of those skills that I talked about in the previous video. So I'm just going to kind of go through them. Go through the steps. I might not show every single thing, but I'll like talk through the process, and then the homework problems that you have to try on your own are very much like these. I picked some pretty easy functions, so you shouldn't get lost in like really taking the derivatives. So they're very much like these, where you're going to follow that same process. Okay, so the first problem had 2 functions. So this is number 1. For each function, I asked you to find the maximum and minimum value, if they exist, on the closed interval. So function A was f of x is equal to x to the 4th minus 10x squared over the closed interval negative 10 to 10. And function B, we'll just end up doing it on this board, was f of x is equal to the cosine of 2x over the closed interval 0 to pi. Okay, so finding maximum and minimum values, or again, if it's a formal problem, let's say find the extrema, over a closed interval was skill number 1 on the worksheet. And so what you are going to do is, for all of these, when you're finding maximum or minimum values on a closed interval, you're going to find your critical numbers, and you are going to calculate the value for the function at each of the endpoints and at the critical number, and then look at those and kind of figure out where's your highest value and where's your lowest number. Okay, so let me go through the process. So first I'm going to find my critical number. So I'm going to take the first derivative, which in this function I'm going to use the power rule. So this is 4x cubed minus 20x, and I want to find a critical number. I want to look at where is this either 0 or undefined. So it's not going to be undefined if you look at it, but where is it 0? So I'm going to say, if I factor out, I can factor 4x out of here. So I'm going to find where is this 0. So I can say this is 4x times x squared minus 5 is equal to 0. So where would this be equal to 0? It's definitely equal to 0 when x is 0. And also, since this x is squared, at the positive or negative square root of 5. So if we square the square root of 5, we get 5. So these are my critical numbers. So I have 3 critical numbers. Okay, so that's step 1, find the critical numbers. Then I want to find the value of the function. So find the value of the original function at the endpoints and at the critical numbers. So I am looking to calculate the value of the function. I like to put them in order. So you'll notice I always go from left to right and just kind of put them in sequential order. So I need to find the value of the function at negative 10, at negative the square root of 5, at 0, at the positive square root of 5, and at 10. So I'm going to take these values and I'm going to plug them into my original function so that I can find the maximum or minimum values of this function. Okay, so if I put negative 10 into the function, to the 4th gives me, the point of I'm saying here, I'm sorry, I'm kind of rambling. Negative 10 to the 4th is going to give me a positive value, and squared also a positive value. So I'm going to find that at negative 10 and at 10 I will have the same values, and same deal here. But, you know, get out calculator, plug and chug, totally fine. So when I put negative 10 into the original function, I'm putting it in here, I end up getting out 9,000 if I calculated correctly, which I think I did. If I plug in negative square root of 5 to the original function, I get negative 25. If I plug in 0, look at that, you can clearly see I get 0. If I plug in positive square root of 5, I also get negative 25. And 10, I also get 9,000. So we can see clear minimum values right here, right? And then these are my maximum values. So we can say our minimums occur when x is plus or minus the square root of 5. So if you want to be official, you could say at negative square root of 5, negative 25 would be my value. Positive square root of 5, negative 25. Again, I'm okay if you just say it occurs at negative 5, or negative, I'm sorry, square root of 5, positive square root of 5. But this would be your more formal notation. And the maximum values occur at plus or minus 10. So we can say negative 10, 9,000, positive 10, 9,000. Okay, so again, recapping my steps. Find your critical numbers, and then calculate the value of the function at your two endpoints and your critical numbers. That's it. So these are pretty simple problems to do. So let's go over and repeat that same thing with this one. So again, we're finding the maximum or minimum values on a closed interval. So first, I'm going to find my critical numbers. The derivative of cosine of 2x is equal to negative sine. So when I use my chain rule, it's going to be negative 2 times the sine of 2x. And so I want to know, where is that 0? We know that the sine of a function is 0 at 0, pi, and 2 pi. And so I basically want to find where 2x is equal to 0, pi, 2 pi, could go up to 3 pi. We'll just see like what we can hit in this interval. And so my critical numbers end up being x is equal to 0, x is equal to pi over 2, x is equal to pi, x is equal to 3 pi over 2. And then at that point I get out of the interval. So these are my critical numbers. Again, these are just places where if I put these values in right here, I'm going to end up with a 0. Okay. So I want to calculate my original function, which is this one, at the two endpoints and at the critical numbers. So I want to find the value of the original function at 0, at pi over 2, at pi, I'm going to erase this now, sorry guys, at 3 pi over 2, and then at that endpoint 2 pi. Okay, so there's like a lot going on there just with the critical numbers, but I'm just going to plug each of these values in to this function. So at 0, cosine of 0 is 1, pi over 2 times 2 is pi, this ends up being negative 1, this ends up being 1, negative 1, 1. You can see we're oscillating back and forth. So my minimum values occur at pi over 2, negative 1, 3 pi over 2, negative 1, and my maximum values occur at 0, 1, pi 1, 2 pi 1. We could, you could figure out, we keep going 3 pi, etc. So I have my minimum and my maximum values. Again, my steps were just to find my critical numbers and evaluate the original function at the endpoints in the critical numbers. So that's all we do with skill number 1. This is kind of a short video, but I'm actually going to separate the other ones into a separate video because I kind of like link them all together. So this is the type of problem we use the least, I guess, but it is still an important skill. So you're always going to see that closed interval, and the closed interval, these are the only places where we see the closed intervals. So the closed interval should be sort of a trigger to you. Okay, this is skill number 1, find my critical numbers, evaluate function at endpoints and critical numbers. That's it. All right, I'll come back for the other ones.